Okay from LLI. So, welcome everyone on this sunny afternoon. This was originally supposed to be a talk for 20 people, but as you can see, it's ballooned up to this size. There are actually 20 accounts for the hands-on lab sessions. We didn't provision more because we did not expect such a huge turnout, but I think it's okay. The labs are meant for flavor and context anyway. So, and the way they are sort of coded up, you could have multiple people interfacing with the same computer. So it's not really a big deal, right? So let's get the introductions out of the way. So my name is Ian. I am the CEO and founder of a training company called SG Code Campus. So we have been in business since 2016. So a bit about myself. I studied applied math and computational engineering at these two places. When I came back to Singapore, I started off as a quantitative risk manager at Barclays, where I stayed for a good 5 years. So I had a good chance to not just be a risk manager, but also work with infrastructure on projects relating to the so-called Basel III regulatory regime, right? So I've got an unusual amount of, shall we say, project management experience that's quite atypical for somebody usually in my role. Started SG Code Campus in 2016 with some people from Barclays. We started off as a institution that was teaching kids how to code, but during pandemic, or just before pandemic, we actually pivoted to the adult training business. Not so much pivoted as it was an expansion, right? So we still currently run quite a lot of youth and teen and kids type businesses, but the adult business has really grown for us. I'm also teaching at SMU Academy under the SSG funded courses, specifically in AWS Cloud, as well as AI ML type courses, right? So that's me in a nutshell. So today's talk, I'm just going to outline, will broadly be sort of covering things across 3 sections, right? So the first section will largely, I'm assuming everyone here doesn't come from a technical background and coming from a business background. So we're going to spend some time to get everybody on the same level with regard to the technical terms, right? So a lot of you might have heard about the terms deep learning, neural networks, but let's just get everyone on the same page, right? I'm assuming that some of you are really technical, so this might be a bit of a bore for you, but please bear with me. So we'll talk about sort of like the advancements and the developments that have happened in the space over the last 10 years, I'd say since 2012, to help put things into context. I'm a strong believer of sort of understanding the context and history of the technology because it helps you understand how they came about and how to actually apply them in a given setting, right? The second part of the talk will move towards business use cases. Now, we're not a large company. I'd say we're an SME. We've been around for 7 years. We're still rather small. I'd say we've got about 40 plus staff, in various positions throughout the company. But we do use generative AI, like ChatGPT. I think this is the 5th time I'm giving this talk. So I always ask the same question, which is like, how many of you have tried ChatGPT? Which I'm not going to ask here because the previous 4 audiences, more than 50% have tried it. So I'm just going to assume that everyone has tried it, right? But I think what has value is what is maybe not so known is the alternatives to GPT. Right, so you've got a lot of choice actually. GPT is not the only animal in the room, right? You've got a lot of, if you find that it doesn't work for you, then from this particular talk, I hope to be able to pull the layer back on some of these other alternatives that you might find useful for you, right? So we're going to give you 3 to 4 sort of specific use cases where in our company it's helped us streamline the work that we do and actually save us like, I'd say tens of thousands of dollars, and I'll elaborate why later with big gory details. So that's the section 2 part, which I assume a lot of you came here for. And finally, we'll just do a wrap up of the trends that are happening in the space. So generative AI is really, every week when I open my news feeds, it's something new that catches my attention. It's just, the space is just moving so fast, right? I'm going to put up maybe 4 or 5 trends, each of which have gotten sort of like a mention in media over the past 2 months, right? And I hope that those trends and my thoughts on sort of like these developments will be able to guide you, for more creative uses of generative AI, right? So with that, I'm going to start with the first section, which is let's talk about deep learning, neural networks, before we settle into this generative AI technology, right? So let's start off with what deep learning is, right? So deep learning is basically just a type of AI. It's an approach to doing artificial intelligence. I'd say that has been around for decades, right? So I think, maybe in the 40s, the question of how to create an artificial intelligence, something that emulated humans and was able to do like cognitive tasks that average human can do was raised as a question, right? So back then, there was no such thing as a department of computer science at MIT. You basically had psychologists, mathematicians, physicists like working together, and they were and neuroscientists working together, and they were just sitting down and thinking, hey, if we're gonna create an artificial intelligence, why not base it off the best intelligence we know, right? Like the model of human intelligence, right? So deep learning, which is essentially a type of AI that uses a model called neural networks, right? The name reveals that the model behind such learning is actually the human brain, right? Well, you can see the 2 scientists that basically came up with this idea were a pair of scientists called McCullough and Pitts. They did some pretty path-breaking work in the 1940s, but I'd say by the time the 1960s hit, their approach was largely shown to be, at least at that point in time, unsuccessful, right? So that led to what people call the first AI winter, where people like governments and institutions and universities just pull funding away because the approach wasn't shown to work at all, right? They were so far away from something that could perform like human level intelligence that, it basically killed the field for a good decade or so. And then there was a resurgence in the 80s, and then it died again for reasons that we might go into if we have time. And then now we're basically in this third wave where it's all driven by happenings that have, or events that have happened since 2012, right? That have led to tasks that have been particularly difficult for AI to handle, right? Specifically there are 3 areas that I would like to talk about, right? So they are highlighted in blue here, right? So I'm briefly going to go into these 3 types of tasks that have traditionally been very difficult for AI to handle. So machine vision is one. How do I make a machine process visual information the way a human being does, right? That traditionally has been very difficult, right? But it turns out that in 2012, we actually managed to get machines that started to look like they had superhuman intelligence. Now, the term superhuman intelligence has a very specific meaning in the field of computer science, and I'll go into what that means later, right? Then we'll talk a bit about natural language processing, which is a big scary term for talking about machines, having machines basically communicate with us in human language, right? Be it written or spoken, right? So that whole field is called natural language processing. And advancements that happened there started to really kick off in 2015, right? And finally, in parallel, the same people that were working on all these models also decided that another human task that was worthwhile to sort of think about and to try to see whether machines could get sort of really good at was the issue of creativity. How do I get a machine to generate truly novel, truly original pieces of work, right? Work could be a novel or like an image or like a video, right? So these 3 sort of blue points, right? 2012, 2015, correspond to sort of like the points in time where machines really started to be able to do things that concern vision, concerns communicating with human beings, and create original content in a way that was quite frankly astounding, right? So traditionally, the approach of using data to train machines to behave like humans is not an old idea, right? It's that field called machine learning. So machine learning is the branch of artificial intelligence where we are basically getting machines to learn from data, right, that they've seen before, and then behave in ways that are consistent with that data, right? But you wouldn't. I think when I say data, most of you are thinking Excel spreadsheets like columns and rows, right? You don't typically think of an image, right, or a set of images as a data set. But this is kind of like where we are moving towards when we talk about deep learning, right, and why it's so astounding. Now, once we've covered those 3 points, we'll move on to sort of like the real topic and the meat of sort of today's talk, which is generative AI for text, which can be seen as almost like an amalgamation of having creative machines that deal in the space of natural language processing, right? So it's kind of like taking the previous 2 blue points and combining them and coming out with something new, right? And then in 2021, you've got this company called Stability AI. They created an algorithm called Stable Diffusion that allows you to basically use text to generate images that are completely original. Right, so this also can be seen as a combination of the previous 2 points, like having machines create images in wholly original ways, right? And this is all fairly recent, yeah? Like, I mean, there isn't a whole lot of material out there, or rather there's a lot of material out there, but it's very difficult for a layperson to make sense of it, because a lot of it is very technical, right? So these timelines are rough, but this is what the literature sort of points to. So you can see we're talking about stuff that, wasn't even in existence. Stable diffusion was only in existence like 2 years ago, right? So this is really bleeding edge cutting, bleeding edge stuff, right? Now, let's talk a bit about deep learning, right? So as mentioned before, the model for deep learning is the human brain, right? So the roots of deep learning are biological in nature, right? So let's just quickly go back to maybe Sec 1, Sec 2 biology, right? This is a rendition of the human brain like a cell, like a neuron, right? You've got a nucleus on the left side, right, where you've got these things sticking out called dendrites, and then you've got an axon, right? So essentially, when you touch something hot, right, the nerves on your skin send electrical signals, and they basically send them through a chain, from cell to cell to cell, and it eventually ends up like in your brain, right? And the way to think about this is that the signal that triggers, the pain receptors on your skin cells, they actually send electrical signals cell to cell to cell, right, until it hits your brain and you go, hot, then you recoil, right? So, that sort of picture, that biological picture, led to shall we say, the model, like the computational model of a neuron, right? So here I put the 2 neurons side by side. You've got a biological neuron on the left side, and you've got an artificial neuron on the right side, right? So instead of dendrites, you now have data that's being fed, right, into sort of like a processing unit, right? On the left side, the processing unit is a nucleus, it's a cell nucleus, right? On the right side, it's actually a statistical model. So for those of you that come from finance, or you might know what a logistic regression is, right? So you don't even know what that is, but this is just for those that know, right? So in the early days, instead of having a nucleus, you actually have like a math model to process the data, and then after the data is processed, out goes an output, right? So on the left side, the output is a combined electrical signal. On the right side, it's basically more data, right? And the analogies don't just stay at the cellular level, right? It actually goes up to the macro level, right? So in a neural network, here you've got a rendition of the arrangement of the neurons in the cerebral cortex, which is your brain, right? You can see that this is many cells in the top picture that are arranged in rough layers going from left to right, right? The layer is a bit more clear on the left side and maybe 3/4 away on the right side, right? And this basically led to the so-called CNN, or convolutional neural network, which is a type of neural network that we use for machine vision, right? So essentially, the CNN is a deep learning model that truly is inspired by the way our vision works in our brain, right? So here you can see that instead of having neurons arranged in layers, you actually have statistical models arranged in layers, right? in a grid almost, like a two-dimensional grid, right? And then each grid basically processes information from the earlier grid and then refines it and moves it forward until it basically comes out the other end, right? So a typical way for you to imagine this, the very stereotypical problem is, imagine you're trying to get a machine to recognize cat or dog. So you give it a picture of a cat, right? So the cat enters as data on the left side, and then it flows through the neural network, right? And the information gets refined until it hits the other side, and then you get a singular answer. Yes, it's a cat, or no, it's not a cat, right? In some sense, our brains also work in a similar fashion, right? So you can imagine like the first few layers process very simplistic information, right? The brain, the V1 portion of the brain, I'm not a neuroscientist, so this is all basically third-hand information, but essentially you've got that section of the brain that's responsible for recognizing edges, lines, right? And then once you recognize a line in like a given picture, that information gets processed to create more complex shapes. From lines you get squares and circles. From squares and circles you come up with the shape of a face, eyes, nose, mouth, and finally you can go, that person is John, yes, no, right? So that's where sort of like the analogy for machine vision comes from, right? So before 2012, I was actually a graduate student back then. Not in 2012, I graduated in 2010. But back then, machine vision, at least at my school, was at a level where people would spend tens of millions of dollars to try to get a machine to do that problem that we talked about, recognize whether there's a cat in the picture or not, right? And the best of the best machines, I think in the 2008 period, right, could only do this with 70% accuracy. That means they got it wrong 30% of the time, right? And we now know that on average, human beings, there are some studies that run, human beings get this type of recognition problem correct about 94% of the time, on average, right? So the machine is a long way away from human level performance in a way that would sort of get us to go, the machine is actually quite good, right? So 70%, 20% error quite jalala, right? So, but starting from 2012, there was a team out of the University of Toronto, right, that basically used a neural network approach. And they managed to get these incredible, these machine vision, ImageNet is the name of a machine vision competition, right? It's basically a data set where there are 1.4 million images across 1,000 different object types, cat, dog, table, camel, whatever, right? And the goal of ImageNet is to basically get people to compete, right, to try the models and to show like how accurate the models can be, right? And what happened was, you can see this is the progression of the performance of the average machine vision models from 2010 all the way up to 2017. Right, so you can see in 2010, 2011, even 2012, we're still getting about 16.4% error. Right, but you can see from 2012 onwards, you start to basically drop pretty drastically, and this is crazy because people have been working on machine vision for like 2 decades, and every year they run ImageNet, the improvement will be something like 0.5%, and suddenly overnight it jumps by like almost 10 percentage points. So this is a big deal, right? So if you understand this in context, this is one of the primary reasons why neural networks gain so much funding, so much attention, so much money, because it crystallized, it started from the ImageNet performance, right? And you can see by 2015, you actually start to get machines that are very, the average model is basically doing 3.6% error on classification tasks, right? And this is what I mean when I say the machines have achieved superhuman intelligence, because as I mentioned before, 6% error is the human average, right? But the average machine in 2015 is doing 3.6% error. And now in 2023, the vision problem for object recognition is passé. It is just like that law. It's not even exciting anymore, right? This is how fast it has sort of moved in a decade, right? So the question you might have is like, all these models of the human brain, they've been around since the 1940s, right? So what has changed, And what has really changed is really the last point, right? The algorithms have always been around. The data has always somewhat been around, right? But with the advent of the internet, you suddenly get a lot more data, right? So I think that there's definitely some contribution coming from that. But the computation part is the most important part. Because it turns out, right, there's this thing in computer science called Moore's law, right, where the average power of your computer processor doubles every 2 years, right? Someone can fact check me on that. I have gotten, but roughly that is the idea, right? So the idea is that with cloud computing, with GPUs, with faster computers, with the ability to network, we suddenly have computers that can crunch out millions of times more, powerfully than they could do like a decade or 2 decades ago. And that actually is the difference, right? Because the proof is in the pudding, right? Suddenly you get machines that basically can do object recognition with 1% error, or even less than that, right? So essentially what has made these things work is basically computers getting more powerful over time, right? So that basically closes my part on vision. Let's talk about creativity. Okay? So when we talk about creativity, it's actually a very different problem. It's actually a much harder problem. Because when you're doing object recognition, you present a picture, the computer is either wrong or right. Right? But when you're talking about creating something that's truly original, you get into a very complex problem. While let's say you're in the business of replicating Picassos, right? Now, if you want to replicate a Picasso as a human being, it's actually a rather difficult task because you have 2 things to optimize. The first thing you need to do is to create a painting that looks like all the other Picassos, right? So that people can look at it and go, that's in the style of Picasso, right? On the other hand, you need to create images that are different enough from the other Picassos that you've seen that people can go, that is an original Picasso. Now, in general, those 2 things, creating something original and creating something that is similar to something like that is recognizable, are in tension with each other. They tend to act in opposite, right? So there's a very little band where people can accept and go, wow, that's truly original art that's like breathtaking, right? And so you're starting to see like this nuance there, right? This sense of, if I'm trying to get a machine to be creative, it's actually a lot harder to do it, right? Now, I like this story because it's entered folklore in the AI space. Essentially, Ian Goodfellow is the author of a book called Deep Learning that's widely known as the Bible of deep learning. It's a difficult book to read, so I wouldn't suggest that you read it because it's all math, right? However, this guy was basically at Cambridge drinking with his friends at one night, and coming back from the bar, he had a spark of inspiration. He was like, why don't we organize the neural networks in a way to force them to become creative, right? And they do it in a way that's adversarial. What does that mean? Adversarial means that they're fighting against each other, right? So how does this work? So I like to sort of analogize this to, imagine that you have an art thief, right, whose purpose is to basically create fake faces, right? Faces of human beings that don't exist. Right. On the other side, you've got like maybe a detective, right? Like a police constable who's basically there to catch these artificially generated faces and to say that's a human being or that's not a human being, right? And the way a generative adversarial network works is that they're actually a pair of networks. On one side, you've got your thief, which is a generator. Right? That's one neural network, and it's just generating faces, right? On the other side, you've got a discriminator who's like your detective, whose sole purpose is there to say, look at the generated faces and go, that one can make it, that one cannot make it, right? So what you actually do is you start off with a generator and you say, I want to create faces of people that don't exist in the world, like completely original faces, right? That can pass off as human beings. So I start off with random noise, which is a fancy word of saying like it's rubbish, it's a rubbish picture, right? It's what you get when you get static on your TV, right? Then you basically pass it through the generator network and then it generates a face, right? And then you pass the face onward to the discriminator and say, hey, discriminator, this face can make it or not? Is it, you think can pass a human being? Then the discriminator will say fake. Or no, it's a real face, right? And the purpose of this is to basically get the generator, right, to keep generating faces and to learn to do so in a way so that it eventually begins to generate fake faces that actually the discriminator cannot detect as fake, right? You generate a fake face, the discriminator goes, oh, that's real, right? So you do this until the discriminator is basically failing to catch 90% of fake faces. Then what you do is you freeze the generator and you start to allow the detective to start learning. right? Because now the detective really needs to catch up, right? Out of every 100 faces that are fake, he only manages to catch one of them, right? So now you freeze the generator and you get the discriminator to start to learn to detect the fakes. Now you repeat this cycle for hundreds of times, right? We call them hundreds of cycles, thousands of cycles. And what you eventually end up with is a generator, right, that is very, very, very advanced at creating human-like faces, and a discriminator that's really, really good at detecting fakes. Then what you do is you just shut off the discriminator, and now you have a generator that can generate human faces, right? Switch for Picasso, switch for Monet, switch for antenna design, for your radio, and essentially you have actually a pretty general purpose neural network or method for generating truly original pieces of work, right? Now you can try this out yourself, right? So GANs were quite popular in 2015 to 2018, I'd say, right? So this is our intern. His name is Keith. He found this app called ToonMe, right? So ToonMe's purpose is to basically take a picture and convert it into a cartoon, right? You might ask, why do we need this thing? Because, nowadays people they're on IG, they're on Facebook, they don't really want to show their real faces, right? So it turns out that toonifying your face is quite an important thing to have, because you might not necessarily want to put your real face on the internet, right? But you want people that know you to be able to recognize the cartoon as you, right? So essentially this is an application of GANs where there is a generative network in the background that is generating, it takes a real life photo and creates a cartoon. Right, so you can, I think this is ToonMe's on both Android and iOS, so you can go download it. I think it's free for, well, freemium model, right? So we're done with creativity. We now move on to how do machines understand human language, right? And this one is the easiest to understand, right? So essentially, we've been trying to get machines to understand human content for a long time, right? Mostly in text form. Right, so this thing has been around for yonks, right? So Siri has been your phone since, I don't know, like the last decade. Google Assistant, Alexa, this is Alexa, right? We'll use Alexa for a demo later. But essentially, the point is not that natural language processing is new. It's more that what has come out in the past 3 years has been astounding, right? So, for example, so to be able to understand why we are so interested in this over the last 5 years, we should talk about what in this space is considered easy versus what is hard. So for example, spell check in your Microsoft Word or your Google Docs, keyword search or finding synonyms, that is just passé, right? People have been doing this for like 20, 30 years, right? So not even a thing anymore. What is maybe a bit more difficult is passing information from websites. So if you look at a website, for example, like this, right? And I open up the, oh gosh, hold on, sorry. Yeah, so you can see this is the HTML code that corresponds to my website, right? And it's a mess, right? Because there's all this information here, say lead the pack code and cloud, but I actually have to dig through all this code to find out the data that matters. So how can a machine basically sort of look at a website and draw the relevant information, ignoring all the nasty HTML code, right? And really pass information. In the vernacular or sort of computer science, we call this scraping, right? So scraping, turns out there are various tricks to get it to work, right? But essentially, it's a much more difficult problem than looking for a spell check, right? And finally, what is truly hard, right, is machine translation. Right, if you open Google Translate in the past like 3-4 years, you can feel that every year the thing is getting better, right? And it's getting better every couple months. That's because behind the scenes, right? Google is basically changing its approach to how it does natural language processing to basically incorporate all these models that we'll talk about soon, right? But essentially, machine translation is incredibly hard, right? Semantic analysis, what is the meaning of something? I read a paragraph and you tell me what it means. That's also quite hard to do, right? And that's actually quite important because oftentimes, I like to say, like, in the age of the internet, we're actually flooded with information. It's not that I cannot, it's not that the thing isn't there, it's just swamped in a sea of words, right? So being able to parse and then interpret information, is actually an important task, right? Especially in an age where we are swamped, right? Core friends I'll just skip, right? But then the last one that is sort of important also is answering queries. right? If I ask a question, do I get an answer back that makes sense to me? And there are a few things that basically are important, like does the thing sound like a human, like does it sound like a human response? Right. Sometimes you listen to these automated like voice machines and it's very jarring, right? Because you hear this automated voice. The worst ones are where they have pre-recorded words and the words are strung together word by word. No one likes that, right? So essentially these are sort of like how we go from difficult to hard in terms of understanding languages, right? And if we can solve these problems, actually the business use cases are immense. Right, you can do online advertising, advertisement matching. You've got automated translation. I think will solve a lot of problems, right? Most of you watch, Star Trek. You got a universal translator, right? So that kind of like is the dream, right? You've got the machine. In fact, actually that kind of already works, right? You've got Google Translate. You can speak to it. I was recently in Japan, and then out comes Japanese. Right, then you put the thing to the Japanese person, and then he talks into it, and then English comes back. Right, it's not quite Star Trek level yet, but I think we're quite close, right? And essentially, you've got sentiment analysis, which is super important. You imagine you're Grab, you've got hundreds of thousands, if not millions, of reviews coming in. How do you know on any given day whether your people like your app or not? You're not going to have 100 interns looking at the reviews, right? You're going to have to do it in some sort of automated fashion. So you can rinse and repeat for any big major company that gets consumer feedback, and that's an important thing to have, right? I won't go too much into the models because we don't have a lot of time, but essentially the way to think about all the different shall we say, innovations in deep learning, the key idea here is that if I want to get a neural network to work on a difficult problem, the best approach is to actually get the neural network to recognize the structure of your problem. What do I mean by that? So when I had the vision problem, for example, right? Essentially the way the brain works is if I have a cat in my right corner of my eye versus in the bottom left corner of my eye, the brain should be able to recognize the same cat no matter where it's placed. Right? So this means that the brain is in some sense what we call translation invariant. It doesn't matter where the object is. Right? And it turns out that organizing a neural network in layers where the neurons sort of can recognize the same pattern no matter where the pattern appears in the grid is the way to actually get superhuman level intelligence for the machine vision problem, right? So the structure of vision in the human being leads to the structure of neurons inside a CNN. For natural language processing, it turns out that some famous person said that the 100% of the meaning in words can be inferred from the 10 words that accompany it. Right, so if you're trying to figure out what someone meant if there's a word missing, you just need to look at the words around it, right? The 5 words to the left, the 5 words to the right of it, and you can figure out what that word was. Makes sense, right? We know this because we put our kids through PSLE, and we make them basically try to fill in the blank, right? So it turns out that what is fundamental to getting neural networks to understand language is to understand that actually human language is actually just sequences of words. So the neural network basically is structured in such a way that it can recognize sequences, right? The so-called recurrent neural networks, RNN, can basically pick up the structure of words in a given sentence and then use that to infer meaning, right? So now we come to the exciting part, which is we're in 2017, right? So we've talked about vision, we've talked about creativity, and we've talked about human language, right? So we start to combine these two things. So you can see this is a timeline. You're starting to see things that you can recognize. So this is a timeline of what we call large language models, right? You can see GPT features a lot in this timeline, but the others are actually just as important to the development of sort of like models that can truly understand us, seem to understand us when we speak or talk or read, right? And these models are called large language models, and it started when Google published a paper called Attention is All You Need, right? And it turns out the cute idea behind this is that, remember what I said about the way to solve a problem using neural networks is to arrange the neurons in a way that follow the structure of the problem you're trying to solve? Well, if you're trying to understand human language, notice that when we listen to somebody, I don't listen to them talking 10 words at a time. I actually listen to them 1 word at a time, right? So I'm actually paying attention to the words, or when I'm reading, I look at the words 1 at a time. I'm attending to the words 1 by 1. So is there a way for me to get the neural network to attend to the words one at a time if I'm given a phrase, if I'm trying to understand what the word or the sentence or the paragraph is trying to say. And that essentially is the idea behind the so-called LLMs, right? The so-called transformer model is an architecture where it focuses on words one at a time, and it tries to infer what the word means based on the words that are surrounding it. So here I've got an example of a phrase, right? And we're trying to figure out if the word flies means flies in the sense of the verb you're flying, or flies the noun, which is the insect, right? And so the way to think about this is that inside a large language model, the words time flies like an arrow, fruit flies like a banana, they're all represented as numbers, right? So this is what the columns below there mean. Like time in this picture is represented by 4 numbers that are colored blue. Flies is 4 numbers arranged in a column that are red, and so on and so forth, right? And the way the large language model works is when it attends to the word flies on the left sentence, time flies like an arrow, it tries to find the words that are similar or in meaning, or can contribute to the meaning of the word flies. So you can see that, you know, in the lower row, you've got the word, you've got that colored, you know, bunch of boxes, blue, green, purple, and green, right? Which tells you that actually that when I'm attending to flies, the word time and arrow contribute to its meaning, or me trying to make sense of its meaning. Right, so what the attention mechanism does is it combines these numbers in a way so that the eventual output is the word source. So source is like a synonym for flies that better captures the context, right, of the word as is used in the sentence. And likewise on the right side, you can see that, you know, if I combine the word fruit and banana, the 2 purple sort of numbers, right, rows, columns of numbers, I end up with this mix of orange and purple in the lower row, right, which turns out to be the word insect, right? So that's essentially how the attention mechanism works for all these. This is how GPT works, right? So how does Google do it then? And actually, once you have this architecture, then it's just a matter of data. GPT-3 was trained on the entirety of the English language Wikipedia, I think as of 2014, the snapshot, right? So trillions of words. And essentially, it's just doing something very simple. Like it's doing primary school English, right? I take the first 10 words of a Wikipedia article, I take out the middle word. Then I try to get the machine to predict what the middle word is. So it tries to, and it does this throughout the entire Wikipedia over and over again. So you can imagine this will take like hundreds of computers working, or if not thousands working in concert over months, right, before it squeezes out a large language model. This is why they're so expensive to create. By the way, this also means that it is impractical for us to do this, right? No matter what company you belong to, if you're not a Google, an Apple, or Amazon, or an OpenAI, it's quite hard for you to do this in-house, right? So we'll talk about that later. So this is large language models, and essentially it is neural networks structured for attention, right? I attend to the words one at a time, and I train in that fashion as well. It turns out that the output of such a thing can do all these incredible things we talked about. It can understand passages, it can complete a sentence, it can answer a question, especially if it has seen the paragraph before. Let's say you ask it like, how old is Lady Gaga? And Lady Gaga on Wikipedia, they've seen it before. It will actually vomit the information out if it has seen it before. But more scarily, right, if it hasn't seen it before, it will try to basically create or generate what it thinks is the answer. Right, which leads to other problems that we talk about. Now I've talked enough. Let's move on to the practical part of today's session. I think you've got Trevor and Hui Liang there. We're going to hand out these pieces of paper that have the login credentials for the Amazon accounts. Right, so the accounts essentially are labeled 1 to 25. So you log in, open up Chrome, right? There'll be a link that you can type into your browser, right? That should bring you to a page where you just enter the account name and password. Only the person in charge at this table does that, right? So if we do this right, 1 to 5 should be the first row, 6 to 10 should be the second row, or 11 to 15, and 16 to 20, right? So while we're waiting to do this, I'm not going to get you guys to log in to ChatGPT because I'm assuming that more than 50% of you have already tried it out. So what we're going to do something today is a little different, right? So what I'm going to give you access to is what we call it the API, right? So for those of you that are not in the know, right, non-technical people, when we communicate with a computer or phone, we communicate with it through what we call a GUI, right, a graphical user interface, right? That means you're using pictures on the screen and buttons to interact with the computer. An API is called an application programming interface. It is for developers to communicate with the computer, right? So an API is essentially a bunch of tools that allows somebody to access functionality, right, that somebody, like a company, gives up. GPT being the most obvious case, right? So if you go to OpenAI, most of you that have signed up for OpenAI, would be able to access it through this link, right? chat.openai.com, right? But then if you're a developer and you wanted to incorporate sort of like the functionality of GPT into the applications that you build, the tools that you build within your company, then actually the chat GPT subscription doesn't allow you to do that, right? You actually need to, I think it's platform.openai for a separate subscription. I think it's like $20-30 a month. I pay for it, so anyways. But the point here is that what we have done is we have identified an OpenAI competitor, right? There is a company called AI21 that is backed by Amazon, right? It's essentially one of the competitors to OpenAI in the generative AI space, right? What we have done is essentially exposed the API for AI21 via the lab that you see in front of you, right? Which will sort of like, it serves as a case study for how you can do something similar in your company, right? Because you can imagine if you're not going to get your individual employees to each sign up for an OpenAI account and use ChatGPT, right? There are lots of like corporate and compliance issues, that abound in that, right? What we are trying to show you here is that you can actually get maybe with a developer with fairly simple skills can basically expose the API to multiple members of your team, right, and share a single account in a way that's safe, in a way that takes care of security, in a way that allows you to log the usage, right? So this is how we've done it, right? Essentially, what we have done here is that we have given you there are 20 accounts labeled SFF001 to 020. They are child accounts of our AWS account. AWS being Amazon Web Services, our cloud account, right? And through the cloud account, I basically allow you to access our Stability AI account, right? Because the reverse would be I'd get all 50 of you to sign up for Stability AI right now and it'll be a mess, right? So let's, for AI21 right now, it'll be a mess, right? So let's go to the, let's proceed with the lab, right? So if I click on this, let's not do that. Let's do this. Bear me, okay. Yeah. So if you person in charge, right, you basically, I'm going to use my own email to log in, but each of you should be logging in as SFF followed by 3 numbers. So 001, 002, and so on and so forth. The last one at the end should be 020, right? So once you do that, you enter that, then you enter the password that was given to you in the piece of paper. It should be code for life, 2023, exclamation mark, right? Mine is going to be this. And you should, if you succeed, you should see something that looks like my screen, except you only have 1 box in the corner, right? I'm the admin for this account, so I got a lot of boxes, right? But each of you should only see 1 box. Now, I want you to click on that box. And as I mentioned, because I'm admin, I got a lot of accounts, right? Each of you should only see 1 line. Okay, all following? All following? Okay, so what you want to do is you want to click on that 1 line and you want to click Management Console. Now, there are a lot of steps here, and a lot of you might be asking, why am I doing all these steps, right? So Amazon really, AWS, the way to do all this is really not the way to do it if you're experimenting as a sole person, right? But AWS really shines when you're working in an enterprise or corporate setting because it allows you to control access for your members out of one single account, right? Which is what we're doing here. But the cost of that is that you got to sort of jump through all these hoops, right? So coming back to here, you should enter the screen like mine. If you type the word SageMaker, now SageMaker is the Amazon cloud service, right, that allows you to prototype AI services. Let's put it that way, right? This thing should come up, so you should click it. All following. If you're not following, stop me by raising your hand. Then a new window should pop up. Yeah. By the way, those of you that know about Google Colab, right? It's not like that. It's just one point click and off you go. Right. So SageMaker is very tedious, but it's built for production. If those of you that are managing systems or PMs will know what I'm talking about. Now there's a little link there called Notebook in the left corner there. Right. I want you to expand it. Okay, almost there. Bear me. Then click on Notebook Instances. Okay. Then there should be a line here, right? And there should be a link here called Open Jupyter, right? So Jupyter is kind of like you can think about it as an AI prototyping tool, right? You click on it. Last step, okay? There should be a file called Generative AI Demo, IPython Notebook, right? So click on that and you're done. Awesome, right? Clap, clap. You all got to this point. 15 steps, right? Now, like I promised, don't be scared by the code. The code is just there. This is me coding this on a Monday night like 3 weeks ago, right, when I knew that I had to give this talk. Like the point about giving talks on generative AI is very difficult because either most people know it from a ChatGPT point of view, so everyone thinks they know what they're talking about. On the other hand, to understand how it works is actually fairly involved mathematics. There's no in between, right? So in coming back with this demo, I wanted to create something where nobody has to code anything. You're just interacting with this, all you need is a command of English and know how to type, right? Essentially what I have here is, if you ignore all the scary code and you come to this thing, this is like a mini app, right? You can use the blue sort of div as an indicator, right? So this allows you to type something, anything, into the text box, right? And as I mentioned before, this is very different from ChatGPT. ChatGPT is, you're having an ongoing conversation with a chatbot. So you can ask it a question like good morning, and it'll say, hey, good morning to you, and then you can continue from there, right? But this is a bit different. This is essentially, I type anything in, and the AI will complete it in the best way it knows how to. So this is super open-ended, right? And to help frame sort of the things you can do with it, I come back to the tasks that I mentioned. What can you get the AI to do? Now that the API is exposed, I can actually get it to complete my sentence, right? So I type something and I hit and I end the sentence halfway, it will continue on, right? I can ask it a question, what is the meaning of life? And I'll see what it says. So some of you are already trying this out. Warning, click the button just once, okay? If you click multiple times, it will queue up the requests, and then the next request will eliminate the output from the previous request, so you won't even get to see what comes out. So just be patient and wait, right? Click the button once, right? Summarization, I put in 200 words, and I get it to basically summarize it in 10 words. I can say summarize in 10 words the following paragraph. I can paraphrase it, right? Which is actually, I think, one of the most difficult things, for academic honesty today, because it's actually very hard for you to, you put in an essay and you say paraphrase it. What comes out is entirely generative, right? No one's ever seen it before, right? So if you're a university professor, how are you going to tell whether somebody's written something original or not? Right? I think it's a problem, right? But anyways, grammar correction, don't need to say lah. Right, and text improvement. So you can try the various ways of interacting with the API, right? Essentially, all this big scary code here, right? I've created a mini app for everybody. Everyone's actually just calling my account for AI21. AI21, right? So it's a competitor of ChatGPT GPT, OpenAI, that's based in Israel, right? And then Amazon sort of backed by Amazon, right? So if I come here, I'm gonna do something like, let's try, what is the meaning of life? question mark, and I click to generate. And it goes da 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 da, blah 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 blah, right? So you can try this, right? So in some sense, it's a bit harder to interact with this thing because it's not like ChatGPT is a very specific type of generative AI. It's programmed or trained to have a conversation with you, right? But this is the general version. And by the way, there's a GPT version of this. It's just called GPT. So when your friends next tell you, I'm going to start a company to put ChatGPT in the app, you can tell them that's nonsense because ChatGPT is just a chatbot that's using GPT as its brains, right? But if you have access to GPT, and it's important for you guys to understand this, the API gives you the flexibility to create an app that can do a whole myriad of things that I talked about, right? Have an idea, right? So if you want a question and answer sort of type app, right? Instead of thinking about it from a ChatGPT point of view, you can just directly call the API, pose it a question, and then see the answer that comes out, right? From a business point of view, it's quite interesting because it turns out question and answer is quite important for a lot of companies, especially because they deal with customer service requests all the time where they're basically answering FAQs, right? So that's quite a common problem for a lot of companies. So I think GPT, the last I checked a month ago, you can give it a list of questions and answers. Right, like let's say someone asks you, what can I do on your website? Then you have a set of sort of pre-canned replies. And if you send this to GPT, right, GPT will do two things. It will basically answer from that repository of questions and answers, but it will craft the answers in a way that sound different each time to let you feel that it's like a human being that you're talking to. You know, so this is quite different from what it used to be before. Before, it's actually quite simple to write a repository of question and answers, and then every time someone asks a question, I just match the question and I return the answer from a database. GPT isn't doing that. Yeah, it is basically in the question and answer space, the AI has been trained specifically to get a repository of questions and answers and reply in as human, realistic way as possible, but still remain factually correct. Right. So I understand that a lot of companies hesitate to use this particular feature of GPT because AI fundamentally is generative. What does the generative mean? It's basically starting from random noise, and the model is guiding it towards what it thinks is an answer. Right. But that randomness that it begins with basically leads to all the little variations that you see in the final result. That's how the AI actually gets you to believe that you're talking to someone original or new, the responses are new all the time. But the other the problem behind that is that you get that tension problem I talked about, right? If you can be correct all the time, but if you want to allow for originality in the answers, you might actually open the door to what we call hallucination, where the amount of generated content exceeds the amount of factual content. You see? Last I checked, and I always say last I checked because I checked this 1 month ago, but the thing moves so fast that I don't know what's new as of last week or the week before, right? But essentially, I like AI 21 because it comes with some sort of almost a guarantee, right? They've decided that this is what they should focus on, right? The question and answer problem. So when you give it a repository of questions to answer from, it hallucinates less than the competitors. Now, this brings an important point up. GPT is not the only animal in the room. It really isn't, right? I think the most important thing is to understand the lay of the land, right? And the way to understand why the AIs are so different is because they're just trained on different data. GPT is trained on Wikipedia, right? AI 21, I understand, is trained on a corpus that is not fully revealed, but includes novels, includes like some articles from God knows where. Right, so the AI that you trained is actually the result of some human sitting at the top of a company deciding, let's train our AI on that information. So the AIs that come out will be fundamentally different because what they learn is fundamentally different. Now, it's important to understand the variation in the competition that's out there, and this is the list, right, of what's out there. Right, so I won't talk about GPT, but I think here are some honorable mentions, right? You've got Meta Llama, which is very interesting to me for reasons that I'll talk about at the end of the talk, right? So Meta is slow to the generative AI game, right? But it has decided to break it open in a very interesting way. Google Bard, yeah, it works, but no comment. So GitHub Copilot is interesting to me because it is a generative AI that's trained on code. Now, why is that important? Because so GitHub. We'll talk about GitHub Copilot later because I haven't gone to the applications part of my talk yet. But I will come, and this will be a very important thing for us to settle on. So let's put a checkpoint on GitHub Copilot and agree to come back to it later. Code Whisperer is Amazon's attempt to compete with Copilot, right? But Copilot is the most advanced in the code generative space, right? Well, by far, personal experience, right? And then we've got AI 21, which is what you guys have played with. We talked about generative text. Let's talk about something newer. Last 2 years, generative images, right? So when we talk about generative images, we're usually talking about a model pioneered. The model is called Stable Diffusion, right? And the idea is this: you say something, it doesn't complete your sentence. It actually tries to create a picture based on your description of what you want to see. Fundamentally, it is the same thing going on, right? The Stable Diffusion algorithm also is trained based on attention, right? But instead of attending to the words one by one in an attempt to complete the sentence, it attends to the words, right, accompanying a picture that you want generated. So when the machine is training, it basically takes a phrase. Let's say I am training a unicorn riding across the sky. I have that caption, and I have the picture of the unicorn riding in the sky, and I send it to the AI, and the AI basically learns to attend to the word unicorn and maybe sky, and decides that those two words are important for generating the picture that I intend to see at the end. So at the end of the day, the ideas that led to generative AI, ChatGPT, also led to generating images, right? Same idea. It's also attention, right? But unlike the text case, which is called self-attention, because you're attending to the words, right, that are fed into the machine, right, by leaving them out. This is called cross-attention, because you are basically cross-referencing the words, the captions that accompany your pictures, right? And I'm not going to go into the model because we are A, running out of time, B, because it's mathematically involved, but I will say the following thing. It's called Stable Diffusion because diffusion in statistics means random process, right? Or random statistics, right? So the way Stable Diffusion works is that it basically starts from random noise, and bit by bit it generates the picture that you want to see, where the attention and the words and the caption guides the eventual flow of the image that you want to see. So let me just give you, okay, so you guys can go back to your thing here. Okay, so here, this is the app for 21, AI 21, which is generative text. But the generative image one is here at the bottom of the screen. This one will take 10 seconds to run. So don't double click the button because you erase the image from the previous line. So I'll just say something like brown fox in a purple tree, right? And I'm going to click generate. And you guys feel free to write whatever nonsense you want, right? And see what it comes out with. Yeah, so it should take 10. So I do end up with purple trees and a fox lah. Right? So I find that a lot of people have tried ChatGPT. Not many people have tried generative images. I'd say about 75% of the population hasn't actually tried it. So you all can go and try, right? And try to type as much nonsense as you want, right? And see what images come out. Right, and when I go going back to my talk, you can do this in the background as I'm talking about this, right? So Stable Diffusion, you can see pictorially what's happening is it starts off with nonsense, random noise, right? And it basically gets the phrase that accompanies the random noise, and then the phrase through attention basically generates and is edged towards the image you want to see, right? So if you say holiday scene in Hawaii, you might end up with something like this, right? Cool. So we're finished. I've just taken you through the last 10 years of development and deep learning. Hopefully you start to appreciate why this field is like getting so much attention, right? In all three spaces, vision, human language understanding, as well as creativity, we're starting to see superhuman intelligence in all these three spaces and combinations thereof. Right. Of course, they're not at the point where we have approached general artificial intelligence. It means you've got a machine that can walk and talk like Terminator. Right. It's not there yet. But for specific tasks, the machines have already exceeded us. Right. Let's go on to maybe the use cases. right? So as I mentioned, we run a small company. We really use we use a lot of generative AI tools to actually run our business. Let me give you a few examples, right? I used to, in 2017, in 2016 when we formed the company, it was all bankers and coders. None of us had a shred of design sense. None, I mean none, okay? So when you asked us to come out with a web page design, none of my team could do it, right? So in desperation, we hired a branding company. After looking through like 5 to 6 of them, we decided to award our branding task, right, to come up with a consistent theme, consistent set of imagery, your color scheme, your branding, all that stuff, right, that a typical engineer doesn't really think about. Right? We awarded that contract to a company and we paid them, I think, $18,000 over 3 months to come up with a branding strategy. Right? And then what came out of that was so unsatisfactory that we just decided to do it ourselves on top of what was created. So that was marketing outsourcing failure number 1. So fast forward to last year, when we decided coming out of COVID that we would start to emphasize a bit more on, because for those of you who don't know, my company is an official training partner for Apple and Amazon. So we do official training, Apple and Amazon branded training for both training software engineers to develop mobile applications as well as cloud applications, right? So we decided that we needed to brand on that, right? And a lot of the branding that came from our earlier businesses like Kids was very inconsistent because, imagine you're a corporate customer, you come in and say, hey, you see Kids like in a happy classroom, then you're like, I'm looking for Amazon training in a corporate setting, so it's like, it's very jarring, right? So we hired another branding agency and marketing company, and Trevor is my partner and my CEO, so he manages all the finances around this thing. And I think we spent how much? 100K? More? In the past 12 months on branding and marketing to what I can only describe as complete and utter failure, right? So we fired them about 3 weeks ago because in the past 5 months we've been basically doing the marketing work ourselves, right? So I hate writing copy. It's the bane of my life. But I can tell you that I'd say 50% of the website copy on the website is written by me and our team, right? And it's very painful. For those of you that run small companies, coming out with a branding message and marketing, if that's not where your skill set lies, it's very painful to do because you can spend a whole week at it and then feel like you come out with nothing, right? But then out pops ChatGPT and we're like, wow, maybe we can get it to write our Instagram post, right? So we just prompt ChatGPT and go like, you're now an expert IG poster that posts for the following topics like computer science, kids programming, blah, blah. And it comes out with, I'd say, copy that is actually quite amazing, right? So you can go and look at our Facebook website. So I think in the last 6 months, maybe about half of them are generated by ChatGPT. Okay, it's not amazing, but it definitely is better than what we're paying for. Let's put it that way. Okay? So marketing copy, right? I'll give you another example, very salient example. SkillsFuture Festival Career Discovery Series. We are running this in partnership with SkillsFuture and Apple, right, to basically drive the mid-career iOS developer program that we are running at SMU, at the Singapore Management University, right? So all the copy here is essentially written by our friend here. Here, iOS Career Jumpstart. Refine the piece of copy, blah, 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 blah. Then I'm like, don't like, shorten by 30%. It's like, then too short. I think the important lesson to understand here is that what we ended up using is not straight out from ChatGPT, but it really helps the process. In the past, I would basically, Trevor and Hui Liang and me and the rest of the exco, we would basically be trading messages on our WhatsApp, just arguing over like a phrase that comes out for IG post. This one, right, we just like, okay, just vomit something out. Within half an hour, you get something that's usable already, right? For those of you doing social media marketing, this has been a godsend. IG post, Instagram post, just start the context by saying, give it some context. You are an IG poster, with the following personality, like bubbly, you talk in emojis, blah, 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 blah. And you can get it to work, right? You can see what else I've been using it for, which is a bit embarrassing. You got D&D, which, if you know what it is, very embarrassing. But, we've got content generation. The next point I want to make is we are in the business of training, correct? And we train learners of all ages, right? So let me go into what I mean. So for education, we actually run this program with IMDA, which is a national data science program. Let me just kill this. Right, and where we take in, oh, by the way, if you guys got secondary school kids, you can apply this program, right? It's fully funded by IMDA. Each kid gets like thousands of dollars in subsidies to learn how to become a machine learning engineer on AWS, right? It's basically, it runs for 9 months, and competition, it's competitive, right? Very hard to get into, but you can try, right? But essentially, the program we run is this fella here. Yeah, right? So we are towards the end of the program, and about 2 months ago, I found myself in a situation where I had to explain a machine learning model that I had studied as a graduate student. So technically, I should be an expert in that particular topic. And I also used it at Barclays as a quant, right? So I was like, I should really know this thing inside out. However, you're trying to explain it to a bunch of 15-year-olds, and you're like, I cannot use the language that I would use to teach graduate students, right? So offhandedly, I just opened ChatGPT and I just quickly typed this. You can see it's June. Explain gradient boosting and machine learning in layman terms, right? And then it vomits this thing out, which actually, if you read it, largely is understandable. Right, largely is understandable, right? And it looks like nothing I would have said. and I was like, in that split second, I was like, I'm just going to read off ChatGPT because it just makes a lot of sense. And this, bear in mind, this is coming from someone that supposedly has spent like a year studying these models, right? Even in that particular case, why? Because summarization is a very difficult thing to do, especially in technical jobs. Actually, the most difficult thing to do is to take a complex math model or piece of code and try to explain it to senior management who are not necessarily technically trained, right, but can understand the business context. That's actually fairly difficult to do, right? We use this all the time, right? You can see that we also use it for curriculum development. And this is a long one, yeah? You are an expert curriculum developer for IT courses specializing in the design of curriculum and instruction of adult professional learners. You have particular expertise in the blah, 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 K8s, Docker, Flask. And essentially, I'm not saying that ChatGPT can entirely replace, oh my God, I killed my Alexa. Hold on. So I'm not saying that ChatGPT can entirely replace the expert, but it can certainly make the job, right, a lot easier to do, right? And I can say that ultimately, we're still generating the bulk of the content, but having something that can summarize points for you, even organize the points for you in a curriculum setting is actually an amazing thing to have, right? I didn't expect to use it for so long, right? Because I was just looking for something to start the ideation process as a curriculum developer for this course. But I actually ended up taking some of its suggestions, and the amount of technical understanding amazed me, right? So presumably, ChatGPT has been trained on the Amazon documentation that was present on the internet pre-2021, because some of the answers are technical, right? And we use this in our company now. I think Hui Liang is also my other AI curriculum developer. Use it, got your own account, right? He's even used his own money to buy his own account pay for his own account, because it's actually just really useful, right? Case study number 3. Now I'll come to my third case within a company, which is website design, right? So our website used to look like this. Like this. This is very 2017 because it was coded in 2017 and hasn't been changed since, right? The problem is that website design has since moved on in the last 5 years to a cleaner, more whites, more spacing, and just cleaner lines all around, right? And flatter, what we call flatter imagery. But it's a lot of work to basically ask of a non-design, trained team to do, right? So when the news around generative image technologies like Midjourney and Stable Diffusion came out, we were like, hey, let's give it a crack. Because Stable Diffusion is actually free, I think, to try, and so is Midjourney to a certain point, right? And then off my slides, you can see that my head tech here, Eric, has been using Midjourney, and Eric's the only person with a design bone in him in the company, right? So essentially we asked him to come up with 8 different website designs for the new website, right? And if you look carefully, you can see how he prompted the AI. This is Midjourney, by the way, right? He says, website homepage mockup for a Singapore-based technology training provider, especially in Python, JavaScript, AWS Cloud for kids, professionals, and corporate training. Design should be clean, modern, user-friendly, featuring a visually blah, 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 blah. But essentially, he's just basically telling it what to create, right? And it generated all this stuff in half an hour. Less. I say half an hour because he generated the image first, then he sent it to sort of like the group chat where we were like, oh, I like this one, I don't like that one. Da, 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 da. Then he just went back and took the designs that we liked and just refined them with more prompting, right? And essentially, you can see the designs are sort of, shall we say, gravitating towards a more graphic-heavy approach, right? And finally, when the team decided that we found something that we all liked, we decided, hey, let's go with that. Upon which, he took the image from Midjourney, and we chose Midjourney because I think anecdotally, out of all the image generation AIs, Midjourney is recognized to generate the best stuff, generally, right? Just the prettiest stuff, right? But then Midjourney comes with a lot of problems because Midjourney, you can only access through an application called Discord. Who knows what Discord is? Raise your hand. Who has kids? So Discord is essentially like it's like a chat for gamers, right? So all your kids know this. I know this because when we run the AWS program for secondary school kids, everybody knows what Discord is, but their parents don't know, right? So Discord essentially looks like where's my Discord? Here, right? It's like a chat interface. It looks like WhatsApp, but it doesn't function like WhatsApp at all. It's actually quite hard to use if you are our age, right? But Discord remains the only way to access Midjourney, which is recognized as best-in-class generative AI for pictures in 2023. So for those of you out there that are looking for ways to access Midjourney in your companies, it unfortunately means for the layperson user, you have to learn how to use Discord, right? But coming back to my story, we first generated the pictures on Discord. But Discord, the pictures are just pictures, right? But for websites, I need them in high definition. So Eric here, my colleague here, basically took the pictures and then fed them to Stability AI, which has a different set of generative image capabilities, right? Stability AI can actually upscale an image. So you give it a crappy picture, 300 by 200 pixels, and you say upscale to 4K or 8K, and it will fill in the blanks. Right? So that's essentially what we did. We have a crappy picture from Midjourney, and we push it to Stability AI. We say upscale to 4K, and we end up with like a 4K image, essentially looking the same. Don't believe me? Well, we can look at our website now. It looks like this. So we upscaled that. Right? Generated in Midjourney, upscaled in Stability AI. If you read I think Bloomberg just released an article about the gaming industry being disrupted by generative AI in images. Because typically in the gaming industry, the most expensive part of generating games actually is the asset generation. That means the characters, the buildings, the scenery, all that. It's actually it's very expensive to create. Like every character on average is like USD 700, 800 to generate, to pay for, right? So right off the bat, if you have a huge immersive game, 70-80% of the budget is actually on the asset generation part, right? So coming back to this, you realize that a lot of game studios are actually using these two tools in tandem. Like Midjourney alone, I think is not enough. Stability AI alone also not enough. But the two of them together, right, you can come up with a workflow where non-technical users can basically generate the images they want to see, and then upscale them or even merge them. So Stability AI also has a very cool feature. It can blend images. So you got an image of, let's say you're in Hawaii and you want to tell someone, you want to tell your, I don't know, your friend that you went to visit Kyoto for a holiday. Then you take a picture of the Kyoto shrine and then you tell them blend, then you come out. You can do that also, right? So how much do we save with this? Like I mentioned, if we send this to a branding agency, I know definitively it's between $18,000 to $30,000. We just didn't spend that money. Right? This is all done in-house. I like it. I would say it's beautiful or anything, but it definitely is functional, right? And definitely an improvement over what it was before, which was this, right? Case number 4, right? Oh, by the way, I think this one is the interesting part to most of you. So I'll just say what the tools are. Midjourney, as I mentioned, only can accessible through Discord. Doesn't have an API. That means you only can interact with it as a layperson. That means you chat with the AI and you get it to do what you want it to do. Then you export the images out, right? So you need Discord to run Midjourney. Stability AI, easier, right? Stability AI has its own interface called Dreamweaver, I believe. Yeah, Dream Studio. Right, so Dream Studio is super nice to use. It's like ChatGPT, right? You can put the prompt here, crash spaceship in a dense forest. I'm not running this because it takes 30 seconds to 1 minute to run. But you can see it comes out these beautiful pictures. You can even negative prompt it, which is you can tell it, I don't want to see the following things. So here I can say, I don't want to see a Star Trek Enterprise inside the model, then it will avoid that picture, right? So you got prompting and negative prompting, right? And then you can even upload an image into Dream Studio, which by the way is Stability AI, right, or Stable Diffusion, and you can get it to amend the image, right? So you got a picture of a spaceship you really like, but you don't want to sort of like get slammed by copyright infringements. So you basically amend it until you see something that you like, right? The cool thing is that you can get an API key for it just by signing up for an account, right? Which means your developer can play with it also, right? So this brings me to my last topic, which is how do I scale a use cases. So here what I've done is, for the SkillsFuture festival that we did at VivoCity 2 weeks ago, we coded up this app, right, which is really a showcase of what you can do by just connecting a whole bunch of AI services together on Amazon. It doesn't have to be Amazon, right? You can use it on Google has a fair number of good AI services that you can probably link up in a similar way, and likewise for Microsoft Azure. But I think this is cool because most of you know what Alexa is, right? So I'm not going to go into what it is, but let's see how this thing works, yeah? Where is my fella here? Yeah, so essentially this is a speech to image app that we generated, right? So I'll talk about how it works later, but essentially it uses Alexa. So I'll say, Alexa, imagine this.
Activated. What would you like to see?
Imagine Taylor Swift riding a unicorn.
Generating. Imagine Taylor Swift riding a majestic unicorn through a vibrant meadow. The pop star should be dressed in her signature glamorous style, sporting a flowing gown adorned with
10
sparkling
seconds
sequins
for
and jewels.
Stability AI to return. Ta-da!
Please try again.
Imagine Optimus Prime.
Please try again.
Alexa, quit. Alexa, imagine this.
Activated. What would you like to see?
Imagine Optimus Prime eating sushi.
Generating. Draw a comical depiction of Optimus Prime, the iconic robot character from the Transformers franchise.
I'll leave this here, okay? Later on you all can come and play with it.
Show Optimus sitting comfortably at the table, chopsticks in hand, as he savors the delicious flavors of sushi.
This is an example of, not great, but I mean, there's Optimus. Okay, I'm going to shut him up. Shut up. Okay, so there is Optimus Prime and there's sushi, but I'm not sure that Optimus Prime is actually eating the sushi lah. But this brings me to my next point, which we'll talk about limitations of AI, right? So this is kind of cool. How did I do this? Essentially, we've got Alexa, which uses deep learning to do what we call voice-to-text capture. That means you say something, and then the Alexa API will vomit what you said out as text. Then you can then pass on to the next program, right? So I use Alexa for voice-to-text capture. Then we take the text and we feed it. Most of you think I'll just feed it as a prompt to Stability AI, but that's not what we're doing. Because if you do that, you end up with very rubbish pictures. Why? Because it turns out that trying to get good performance out of your generative AIs requires you to carefully craft what you want to say to the AI, right? The so-called prompt engineering, right? So I won't say it's a science, right? But it turns out there's a way to prompt generative AIs to get the type of results that you want. Right, and in this particular case, you can see what is actually happening is, remember I said, imagine Optimus Prime eating sushi, right? What I did then was I then fed imagine Optimus Prime eating sushi to AI 21, right, with a prompt to generate a full Stability AI prompt. That means I'm telling the AI to give me a better prompt for the next AI. Understand what's going on here? which is where this comes from. Draw a comical depiction of Optimus Prime. That means based off what I said, the 3 to 4 words, AI 21 generated a more complex prompt, filled it out, expanded it from 5 to 7, like 70 words, and then the 70 words gets fed into Stability AI for the image generation. That's how you get higher qualities. This is a trick, right? You can get the AI to AI itself back, right? So this is one of those things where you sort of like get a sense of after watching like YouTube videos and just staying on top of the matter, right? So if you're interested in this, you can actually do some searches for here. Right, so I like the AI 21 prompt engineering tutorial. Essentially, I'm not going to go through it because it's a lot of time. You can read it yourself. It's like 2 pages, right? And whatever they say about prompt engineering works for all generative AI. So you can follow the approach from Midjourney. You can follow the approach for ChatGPT that's laid out here. And I really like the example here. It's very clear, right? So definitely just look for AI 21 prompt engineering, and then it's 2 pages. It's like 20 minutes of your time. So go read it. It will just make for a better prompt. And you can use prompt engineering in ChatGPT. That means ChatGPT give you nonsense results, right? You can refine your results, right? So essentially, this is another hack for you to sort of enhance the results you get out as you're playing with these technologies, right? Wow, we're at 4:30. So let me just, we talked about AWS. I wouldn't say that we use AWS because we are AWS partners and we know the AWS cloud inside out, right? But if any of you are using cloud services, which is a fancy term for data centers for rent over the internet, right? In today's world, at least in Singapore, there are maybe 3 major players. I'd say 2 major players. AWS is one. Right, they own 30% of the global market. The next 20% comes from Microsoft Azure. Together, the 2 companies dominate 50% of the cloud market, which is basically every company, SME, or individual that wants to put something on the internet is using these 2 services, right? Then the Google Cloud Platform is a distant third. They're like maybe 9% of the market, and everything else is a tail. Your Ali Cloud all the Chinese cloud providers, for reasons that I think are more related to language barriers than anything else, right, are essentially the tail of the market, right? But what I say here is true for any cloud, right? So the idea here is like, I think if you want to get people to try this out in enterprise, you can get everybody to sign up for the ChatGPT account and pay for it, but it's just very clunky lah. If you've got a developer, which lots of you in fairly medium to large companies do, you can basically go to the cloud and then get your developer to build simple applications that access the API and do things like put in some basic security, right? So for example, AWS, if I throw in Cognito, I can get login for free. So, and then I can even log, right? As somebody is making the call to Stability AI, I can actually log what was said. and then store it on a database, right? So Lambda is essentially a service that allows you to almost like pass through the request, right? You get, that's what all of you are doing here. All SFF01 to 020 are just calling AWS Lambda to call my account. I say my account because I'm actually paying for it, right? Not the company. So you're all using my account, right? And that way I can freely allow you all to use my credits. I think it's like $10 for 5,000 images, right? But I'm not going to share my password with you, but I don't have to because I did it like that, right? So I think in that case, you guys use SageMaker. SageMaker is kind of like, for those of you in the know, it's Jupyter on AWS. For those of you not in the know, it's an AI prototyping tool, I suppose, right? If you guys are in data science or you're a data scientist, they will know what we're talking about. So that allows you to basically have multiple data scientists basically calling a single API. So you don't have to get multiple accounts for people. And it just makes it easier for monitoring and logging and compliance, right? Agreed? Right, in an enterprise setting. Amazon Bedrock is a new service that's launching this month. It's essentially, shall we say, Amazon's answer to Bard and OpenAI from Microsoft, right? It's a bit late, but I think Amazon is really not in the game for creating the most groundbreaking AI. They're not. Amazon is the world's largest cloud vendor. Their business is to basically give you the data centers for you to put your stuff on, right? So this is really just to stay in the game. I think for them, they have to be in the game, but they don't really have to be on top of it, because as long as, I think the majority of most data science loads, there was a study done by Gartner, which is an industry sort of like heavyweight in this space, right? That said about 80% of the production loads for machine learning and data science actually lie on the AWS cloud. I can pull out the statistic because we use it in our lectures for the cloud course, right? Which is pretty astounding to me, because I'm like, well, at the end of the day, when you decide to put your infrastructure out for the world to use, you can't go wrong with Amazon. And that's what people are using. They're choosing with their money, right? So I hope to, through this, we've injected some flavor, our own perspective of how to scale these things out within an enterprise situation, or maybe even an SME situation, right? Which you might not have easy access to, right? I think this is the point of these talks, right? To basically give you something new to sort of like ruminate on, right? So this part, I believe, if you've got any questions, you can ask us. I'll leave sort of like a link for you to contact us. Our preferred communication channel is Telegram. There'll be a link later for you to sort of contact us there. But if you're interested in this space, we are very interested in this space. Happy to share our thoughts. We're not a company that sort of, I don't think this is a competitive advantage. I think the more people are using this, the better, right? What are the known limitations? So you've already seen a hint of it. Just now when we were using Alexa to make Optimus Prime eat sushi, you can notice the picture is not quite what we want it to be, right? So I'd say generative AI is not at the level, especially for, actually not just images, but for text, everywhere, right? Like oftentimes you're in a situation where like, it's kind of there, maybe 60% of the way, but 40% of the way is like, I can be playing the AI for like 2-3 hours and just not getting what I want. So maybe the way to approach it in these times is to understand that it does help you get past maybe the difficult hump, the tedious 50% of the work that you have to do when you're creating original stuff, right? And then you should use it as an accelerator to sort of make your life easier, right? To streamline your workflows so that people are not doing repetitive work. The way that we did our website design that I just shared with you, right? I mean, we got like 8 people in our company to weigh in on the design that was generated in Midjourney in like what? One afternoon, right? Most of you, if you've worked with the design firm before, you know that this is a 3 to 4 month process we're talking about, even for a small company, right? I have a picture here that was drawn from the Wall Street Journal. It shows you some of the limitations. Essentially, this AI is, you're getting a generative AI to generate a character for a game, but you can see that what the AI generated, the hand is imperfect. Can you see? The finger, the little pinky is like just skewed. And there's no way you can fix that. I mean, at least from the way I have seen the tools work, right? So you still need a human being with Photoshop skills to come in and essentially touch it up. right? But it takes you through, it's 90% generated. So you just need to work on 10%. I think this is the approach that we should adopt towards using these tools right now. It's not a drop-in replacement. Does it destroy jobs? I definitely think that it'd be a lie if I didn't think that was the case. There are some, obviously, I don't have the time to show you the showcase because we are running out of time. We've got 20 minutes left. But Eric is here basically to show you GitHub Copilot, which is generative AI for code. I think, Eric, can you just quickly show, just take over and just quickly do something in 2 minutes to show the power of Copilot? Let me, yeah, you can share your screen now.
Yeah.
So GitHub Copilot is essentially generative AI that exists, that's built on GitHub, right? Which is bought over by Microsoft for 7.5 billion USD in 2018, right? The way to think about GitHub is like it's Facebook for coders. Instead of posting pictures, I'm posting code, right? So there's a lot of open source code on GitHub, and essentially this is what the AI is trained on, right? So what Eric's going to show you is how GitHub Copilot works. It's generating code just from simple English descriptions. Eric, you want to show?
Yeah. Okay, so let's say I'm trying to work on my project here, and I'm trying to run some sort of test on my project, right?
Yeah, go.
Yeah, it's running right now. Okay, so after all the tests has passed, I can see this report, and there's a problem here, right? So I can see that I didn't manage to test every single execution, every single logic in my application. So it's trying to say from line 36 to line 45. So I'm basically going back into my code, and I see, oh, this functionality, right? So I didn't write tests to cover this functionality. So what I'm going to do here is I'm going to use GitHub Copilot to assist me to create tests for this functionality specifically. So what I'm going to do is that I'm just going to highlight this code over here, and I'm going to just go onto my GitHub Copilot, generate me unit tests for this method. Right. So it's gonna go on.
You see the code generating?
Yeah. Right. So looks pretty good. So what I'm going to do here is I'm going to go ahead and open my test file, grocery test.js over here, and I'm gonna insert those generated tests in this section here over here right now, right? Okay, so there's one thing about generative AI, and especially GitHub Copilot over here. It's not perfect, right? So, for example, I don't add my items like this. I definitely added my items using this syntax over here, and you see all these suggestions coming off my screen. So this is essentially GitHub Copilot as well, detecting all the relevant context of the application and generating suggestions based on whatever you're trying to change here. So I think I need to change this as well. So it's a banana. It's 0.99. Right?
Okay. I think okay. Thanks, Eric. I think we're running out of time, but I think the main point has been illustrated, which is when I used to work at Barclays, for every one project manager, you've got a software development team of maybe 5 developers, right? And you're building functionality. And then before the software gets released, you will send it to a testing and a quality assurance team, and there may be 10 to 20 of them, maybe sitting at offshore location. So testing and quality assurance in the realm of software engineering is actually one of the most tedious things to do, right? Because typically, to put it in very layman terms, every piece of code that you write, it needs to be covered by a test, so that when it breaks, you know exactly what is broken, and then you can go and fix it. So essentially, you have to cover your code with tests, you see. But it's a very tedious thing to do manually. Can you imagine you've got a code base of thousands of lines of code, then someone changes one line somewhere, and suddenly that test is uncovered, then you have to go and, So actually what Eric illustrated just now is GitHub Copilot detects where the code is untested, wrote about 20 lines of code to test it, and then you can vomit the code back into the interface and run it, right? Why do I use this as an example? Because testing is one of the more tedious but more rote and routine things to do in software development is in some sense, the easiest way, one of the easier things to, well, it should be easy to automate before the advent of AI, but it just has been very difficult to, let's put it that way, right? But with this, you can do that, right? Hui Liang teaches AI, so he also used GitHub Copilot in an educational setting. Sometimes when we're teaching AWS services, I tell you the problem is that AWS services change every 3 months, right? I fall asleep for 6 months and suddenly there are like 10 new services I've never heard of. You know, this is the problem when you're working with the world's largest cloud provider. So honestly, sometimes when we're teaching a certain service and we're writing a code demo, the code demo actually doesn't work because something has changed, right? And what has proven to be very, very useful for us is that I will just basically ask GitHub Copilot, I just describe in English what I want to see. I need to have a server that accesses Cognito to basically allow for an Android app to log in with tokens that are stored in a particular manner. I actually say that to GitHub Copilot, type that in, and boom, out comes out the code, 100 lines. It works, right? I'd say it works maybe 60-70% of the time. Where it doesn't work, I can amend the 2 to 3 lines where it doesn't work. This to me is astounding. It is really astounding because I think this is actually a development. You know, I think just as recently as 3 to 4 years ago, people will say, oh, like the AI will basically drive developers out of a job. I used to say this nonsense lah, because I'm in the business of training people how to code, right? At least that's a big part of our business. But if you ask me that question in 2023, after working with Copilot for almost 6 months, I would say it is a real thing. Yeah, it really is a real thing. There are some articles that I'm about to show. So I'll talk about trends now, right? We'll cap off here. I'll go very fast. I'll try to finish this all in 5 minutes, right? Trends. Meta Llama is interesting to me. Why? Because GPT-3 is 175 billion parameters, which is roughly the size of the model, right? And there's a linear relationship between the size of the model and how much storage you need, memory to store it. Now, Facebook or Meta Llama, the name of its model, are much smaller. So they have 4 versions, 9 billion parameters, 13 billion, 33 and 65, if I'm not wrong. All smaller than GPT. GPT 175 billion, right? Last year there was like a contest among all the big sort of tech firms to compete to see who had a bigger model. But I think Facebook has taken the opposite approach. It basically is late to the game. It's behind Google. It's behind OpenAI. It's behind all the competitors. So what has it done? It has basically trained its own large language model and then completely released it for free. Right? So if you look at GPT, you actually cannot access the core GPT model. It's hidden from you. You just can't access it. You can use it, you can pay to use it, and you can pay to use the API, but you actually cannot tweak the model the way that you can't own it, right? Meta Llama is entirely open source, which means that this thing is basically posted on a site called Hugging Face, right? Which we will talk about later. But essentially, it's like a hub for free AI models, let's put it that way, right? And this thing is interesting to me because at 13 billion parameters, Llama has shown to be able to do a few things. The first is at 13 billion parameters, it's almost 20 times smaller than the GPT. It beats GPT on some important benchmarks in terms of performance. Second important thing, at 13 billion parameters, you can store this thing on 64 gigabytes of RAM, which means that you can take Llama, load it into a MacBook. Fine, the MacBook will cost you $6,000, but you can put it on a computer, and then you have an entirely offline generative AI. Doesn't need the internet to connect. That to me is an advent of something, because it means that if I can do that today, I think I'll just have to wait another couple years, maybe, before you can put it into a refrigerator. I don't know, right? But it's definitely moving that way. So this is the most interesting to me. That's why I put it number 1, because it's the most interesting development to me in the last 2 months, right? And people, it's interesting to developers. But I think what is lacking is the interpretation for the general public. Why Llama is interesting, right? If you've got somebody that understands this, you should be building stuff off this because it's open source. So all your concerns about like your licensing, your this or that is not really an issue here. I believe it's covered by the Berkeley software distribution. If not, something permissive lah. It allows you to build your own stuff off it. So very, very different approach. Meta says, okay lah, I'm behind the game, so I'll spoil the game for everyone. So essentially, this is the way you interpret it, right? This one is a bit technical, so I don't have the time going through it, so I won't go through it. But essentially, the headliner is this. In statistics, it's very difficult to find an effect if you have less than 30 data points, right? Those of you who've taken statistics in uni or secondary school know this, like your so-called small sample statistics, very, very difficult, right? But LLMs have an astounding property that has been discovered in the last couple of months. You can use an LLM, input data, let's say I got 5 data points, and I want to predict a 6. It turns out that the performance is not bad. So, and no one knows why it works. So you got panel of Excel data, you got only 10 data points, you want to predict 11th, you can throw into a LLM like GPT and see what it gives. So these are a couple of studies that have studied this point, right? Here's the cryptic sounding applying LLM to tabular data. Essentially what you're doing is you're basically running prediction on LLMs. It shouldn't work. There's no reason why it should work. In fact, the papers don't explain why it works. It just somebody decided it'd be a good idea and tried it out, right? I've seen one numerical study on Archive, which I think is very interesting because it shows that it's very easy to test whether a model works or not, right? Because if you have 1,000 data points, you just withhold 900 of them and use 10 to train a model and then see how it performs on the other 900. Then you can compare between models, and it turns out that using LLMs actually is better than almost any other approach if you have less than 30 data points. I'm just distilling the information for you. This is very, very new stuff. It's 2 months old, right? I will watch this space because while in the real world, it's very common that we have less than 30. Beyond 30 data points, you've got your central limit theorem and all the other law of large numbers come into play, right? I mean, for those of you technical, but here there's a way for you to have another black box to answer your question, right? Especially when you're lacking data. Which industry, when we talk about disruption of AI to industries, which industry should I look at? Look at the gaming industry. This article is 2 days old. Bloomberg. AI is rewriting the rules of a $200 billion game industry. Look at the article. Everyone gets 2 free Bloomberg articles per month. So I think you should read this one, right? Because it explains why the gaming industry is particularly vulnerable. All right, because the code can be generated, the assets can be generated, everything can be generated. So if you read the Bloomberg article, the survey says that the bulk of gaming companies in Japan, they interviewed a big one, said that within 5 years, I think 70% of the jobs could be redundant or rationalized, which to me is astounding. So I think if you are looking for disruption, an example of disruption, and trying to figure out if it applies to your industry, you should look at this one first, because this is almost like the canary in the mine, right? Then if this deteriorates faster than expected, or slower than expected, then it would have implications for your own industry, because it would have implications for how exposed you are, right? My immediate family, they're all doctors, like brother, sister, mother, father, right? So for them, the worrisome thing, I suppose, is can the machine make better diagnosis? I think in particular, I think the answer has been quite definitively answered. AI in general probably makes better diagnoses than the average doctor on certain, especially in rare cases that are not seen. And people are already training LLMs on medical text, the so-called Lancet, right? For those of you got people in the know, Lancet is like a medical journal over the last, I don't know, 100 years, maybe I'm exaggerating. Imagine that you got an LLM trained on that corpus. You have a super diagnostic machine, I feel, right? So we're getting there, right? Same thing for legal, right? AI replacing coders, I just talked about it, right? But you can basically take the word coder and swap in any white-collar job. I feel law is particularly vulnerable. At least in America, I think it's a rite of, even in Singapore also, it's a rite of passage for young lawyers to basically do all the grunt work, right? Research lah, write paper lah, this lah, that lah, right? But now you can get AI to do it. So all your menial work, not menial, but like the grunt work is basically being replaced. So that leads to implications for whether our lawyers are getting properly trained, right, in the age of AI. So I think I think I'll just terminate my talk here. I actually gone on for much longer than I thought I would. If you want to talk to us more, you can hit up, use the Telegram chat. It will be open for a week, right? So when you're on it, you can ask us questions. I don't want to release these set of slides because there's some stuff that is in other courses, but I'm happy to share the parts that talk about use cases. You can always ask us on the channel about specific questions relating to generative AI, or you can just hit our website, right? The website has multiple channels to reach out to us. Okay, I will kill my talk here. I hope that you guys had fun on this talk and has been informative. As mentioned, we do run a variety of courses in Python programming, software engineering, and data science ML at SMU. So if you guys are so interested, you can inquire about those as well, and we will direct you to SMU, right? I will stop here. I think pass over to our kind LLI colleagues. Sorry, I ate up so much of your time. Do I just pull or I just pull out? Yeah. Oh, no worries. Yeah, okay. Hey, no worries.
Okay, hi, good afternoon everyone. Thank you Ian for the sharing. Shall we give him a round of applause first? It was really good sharing. Really interesting. How many of you here have used ChatGPT before? Oh,
Everyone,
including me, okay? I think it's very fun, okay, as something that,